Hey students, welcome back to geometry. We're going to start a new unit on area, but this time of polygons. Next we'll deal with other stuff later. But we're going to talk about area of polygons, the whole unit. We're going to kick this party off with parallelograms and triangles. Now a lot of this stuff you've seen previously, so we're going to dig a little bit deeper. And again, I'll try to cut this down in size a little bit, trying not to talk too long for each video. But we're going to talk about area of a parallelogram, finding dimensions, which is nice and fun, area of a triangle, and then area of an irregular figure. We'll get there. We'll make some stuff challenging along the way. So let's do that. Let's begin with notes. Yay! Okay. So we're going to start with the area of a rectangle. Now, first of all, you got to know what the heck area is. Area would be nice to know. So first thing is this. You have a distance, right? So there's some type of distance, and you can totally measure that with a tool, like a ruler or a measuring tape, right? You can have a distance, you can measure a thing, and then you can have, distances can do all sorts of stuff. Yay, distances, right? And so you have all these distances, and you can measure them all, and then you have like a distance around a thing, which of course is perimeter, right? So you remember perimeter. You can measure everything, and that's a distance, right? So this one-dimensional thing, that's a distance. So what then is area? Well, area is this. The flat surfacey part of a thing. That's area, flat surfacey. So you have to see the difference between a distance, right, from the thing that you can measure, and a flat surfacey thing. Now, how do you measure flat surfacey stuff? You can't do that with a ruler or measuring tape, right? So you can't just measure like that, but we can use math. Yeah, math. Math is awesome. So when we talk about area, we talk with the most basic of area shapes, which is the area of a rectangle. And the area of the rectangle is the product of its base and height. So if any rectangle, any type of surface, and it is a rectangle, you can measure one dimension, one base, and measure another dimension, right? The height, and you multiply the two, and you get area. Whee! So one thing we have to know is that distance or perimeter is measured in units, right? And then area, area, when we multiply stuff, gives us square units. So that's pretty significant piece there. So make sure we understand that, right? So when you measure with perimeter, you get like inches or centimeters or miles or whatever. With area, you have square inches, square centimeters, square miles, etc. It says what area is. Then we're talking about the rectangle area here, right? Area based on height. All right, so what about of a parallelogram? So when we're talking about the area of a parallelogram, it's the same thing. It's base times height. With a parallelogram, you have a base and a corresponding height. And notice the word corresponding. So in this diagram here, if your base is the base, the corresponding height is what will be perpendicular to it. Okay, the altitude to that base. Perpendicular to that base, that's the height. Okay, so here's my what if. What if we just beep, 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 move the parallelogram around? Now we have a different base, right? So we're going to have a different height. So what happens if we move the parallelogram around, we'll get it this way. Here now is the base. Well, what is then the corresponding height? The height perpendicular to the base, okay? So we have to understand, when it's all about perspective, don't let gravity mess with you too much. So area of a parallelogram, base times height. Corresponding height, that is. Let's do some work. Yay! All right, so the first example. Huzzah! What is the area of the parallelogram? Well, you see we have a base, right? The 5 inches is our base, and the 4 inches is the corresponding height. So we're simply going to multiply base times height, which is 20. Right? So 4 times 5 is 20. Now, if you leave that, I'll have to smack you a little bit. Because remember what I talked about in the notes. In area, we're dealing with square units. So we can't just say 20. 20 what? If you say 20 inches, again, pop. 20 inches square. You can multiply inches times inches. Right? So you get 20 inches squared. Now, what did he just say? Well, we have 4 inches times 5 inches. Right? So it's 4 times 5 times inches. Oh yeah. Oh yeah. Let that sink in. 4 times 5 times inches. So that's 20 inches squared. Okay, so you got to be careful. Units matter, folks. 20 inches squared. Next example. Oh no, it's a tilted parallelogram. But remember, with parallelograms, you have your corresponding height, right? So the base here is 2 centimeters. That's our base. And the 3.5 centimeters is the corresponding height. And so we're going to multiply 2 centimeters times 3.5 centimeters. Okay, so that's 2 times 3.5, which of course is 7, right? But we have centimeters times centimeters, which gives us, again, the area unit, the square unit. So that's 7 centimeters squared. Units matter, folks. Don't mess that up. All right, then, oh, a little word problem. Oh, no. What's the, excuse me, what's the area of a parallelogram with a base length 12 and a height of 9 meters? Okay, so we're dealing with meters now. It's totally doable. We're just going to multiply base times height. 12 meters times 9 meters. 12 times 9 is 108. Meters times meters, meters squared. Okay, so 108 meters squared. Piece of cake. Let's make it a little bit more challenging. Yay. The challenge. So we're going to go from, crawling into marathon running. Yay. Here's a parallelogram, ABCD. What is DE to the nearest tenth? So basically we're going to be looking for this. This is our question mark. What is the length from D to E to the nearest tenth? And man, look at this stuff. Well, I have a base of 9.4 inches, right? But where's my corresponding height? I have no corresponding height. I'm actually looking for the height. Dang it. So we have a base. We're looking for a height. If only we had the area. Wouldn't that be nice if we had the area? So we need the area so we can find the height. Now, how's that going to work? Look at this. There's like this crazy thing here. I've said it before. I'll say it again. Don't let gravity mess with you. Turn the picture around. Now we can see some interesting things. Now when we turn the picture around, hopefully anyway, you can see a lot more clearly that the 13 inches is your base. Do you see the height now? Yeah, I hope you do, because it's right there. It's 9 inches. So there's our height. So the area is 13 inches times 9 inches. Okay, so that's important to see. So we need the area. We can simply multiply 13 inches times 9 inches. So 13 times 9 is a number, over 100 anyway. So 13 times 9 gives us 117. So we have 117 inches squared. And we already have the base that we're looking for. Okay, so remember the question. We're looking for DE. What we have now is the area, 117 inches squared. So that means we were multiplying 9.4 inches times something, right? Times some question mark, and then that would give us 117 inches squared. So how then are we going to figure out the question mark? Of course, we divide by 9.4. So we will divide both sides by 9.4 inches. By 9.4 inches. Okay, and again, units matter. You'll see why in a second. So all we have to do is divide 117 by 9.4, and we get a pretty, significant number showing up in our calculator. But we're going to round to the nearest tenth. So to the nearest tenth, we have 12.4. But what about those units? We have square inches at the top, inches in the denominator. One of the inches is going to cancel out, leaving us with inches. Oh, sweet. So we have 12.4 inches. Again, units matter. So we'll be careful with that. All right. One more example. We'll call it a day for this video. We'll come back with triangles and such. So here's the words. A parallelogram has sides 15 centimeters and 18 centimeters. The height corresponding to the 15 centimeter base is 9 centimeters. What this tells us, the height corresponding to the 15 centimeter base is 9 centimeters. We now have the area of the parallelogram. Okay, so the question becomes, what is the height corresponding to the 18 centimeters base? So it's going to be, what's the other height? Very similar to what we just did here. We have the area. Now we can find the other corresponding height. So we'll set up our multiplication, right? 15 centimeters times 9 centimeters gives us the area. Okay, so a little more calculator work. 15 times 9, 135. So we have 135 centimeters squared. That's the area. Now, what is this question asking? We have to be very careful. The question is asking, what is the height corresponding to the 18 centimeters base? That means I'm going to multiply 18 centimeters by some height, and I will end up with the area, right? The area of 135 centimeters squared, square centimeters. So I have to figure out that height. That's what this question is asking, and we have to be careful with that. So all we need to do then is divide 135 by 18. So we divide both sides by 18 centimeters, divide both sides by 18 centimeters, and the height will be 7.5 centimeters according to the other base. All right, so we got to work our way around a parallelogram a little bit. And that's basically it for this video. We'll call it a day. We'll come back for triangles in a second. And I hope you guys take care. Peace.